Hi, pre-calc class. Today we are going to start our adventure in graphing trigonometric functions. I think you'll find that these are pretty interesting and they have a lot of uses. So we can mirror and model a lot of things based on these functions, like for example, sound waves, the tide, temperatures. There's really an abundance of ways that trig functions are useful. And if you're continuing on to an engineering field, or at least into calculus, these will become very valuable to you. So we're going to talk today about what a periodic function is, and also the parent functions of the sine, cosine, and tangent graphs. And your learning targets are: I can identify a periodic function, and I can identify a function's period. I know those sound really similar, but they mean two different things. The first is just looking at a graph and saying yes or no, it follows the rule of being periodic. And the second piece is, if you say it's periodic, then how much space or how much time does it take for that graph to start its next period? So we'll hash that out in just a sec. Then we also are going to transfer the sine, cosine, and tangent functions from the unit circle to a graph. And we're going to identify key characteristics of the trig parent functions down below. If you look in the attachment in the assignment, there is a notes page in where we will graph the sine, cosine, and tangent function. For this piece, though, about periodic functions, you can just jot this down in your notebook or somewhere before you start the assignment. This isn't actually on your note page. All right. So we're going to start by talking about what it means for something to be periodic. Period is nothing more than a cycle. So when we think about a periodic function, it's something that cycles through. Now, a while back, we looked at the unit circle, right? And we know that on the unit circle, we can start at 0 and we can go all the way around the unit circle, right? And that's a full 360 degrees. Once we go past 360 degrees, let's say 390, well, that's a full circle plus 30, we'd end up here. And so the values for 30 degrees and the values for 390 degrees, those are the same values. If you remember, we call those coterminal angles, angles that begin and end in the same place. So 0 to 30 or 0 to 390, those have the same values. This function starts to repeat, and therefore it has cycles. We call it periodic, right? Every time we get to 360 degrees, we get to repeat and repeat and repeat. And you can do this infinitely. Ooh, it's like mesmerizing. But that is the idea of a periodic function, is that it starts to repeat. So when we look at this outside of the unit circle here, a periodic function is just a function that repeats its values in regular periods or intervals. And repeating its values, when we say that, we're talking about the y values, right? So when I look at graph A here, it starts here, down to 0, up to 4, down to 0, up to 4, down to 0, up to 4, down to 0, up to 4. Again, I'm focused on the y values here. So we went from 0 to 4, and this graph, the shape of it is just repeating itself. So that would make this graph here periodic. And if we say it's periodic, then we want to figure out what is the period. So how much space, or how big is the interval where this graph starts and ends before it repeats itself? And you can really find any starting point on this graph. It should have the same period. Excuse me. So let's pick maybe 0, 0 as a starting point. This graph goes up and then back down. And once it gets to this spot here, that's when it's going to start to repeat. It would start to go back up. Well, it stops then at 4. One period of this function is from here to here. And the distance, or the interval, is 4 spaces long. So the period, we say, would be equal to 4. Now, I didn't necessarily have to start and stop when it's hitting the x-axis. Look at what happens if I wanted to look at the period from the top of this peak. It goes down, comes back up to the top of the next peak. So I'm waiting for it to get to the next spot where it would begin to repeat itself. Well, that top peak is at 6. The furthest right top peak is at 10. That's again a distance of 4. The period is still 4 as long as you are always beginning and ending before the graph begins to repeat. So this one is periodic with a period of 4. Now let's look at B. Okay, so this graph looks like little steps, like the greatest integer function that we graphed. Here, the shape of the graph repeats, right? Line, 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 and you have an open circle on the right, closed circle on the left. But think about, do the function values repeat? Do the y values repeat? So here we're using a y value of 1, of 1/2. Here we're using a y value of 1. Here it is 1.5. Here it is 2. Here it is 2.5, and it continues up in that fashion, right? So if I am looking at this graph, could we say that the y values are actually repeating? No, I don't think we can. We never use 1/2 over and over and over again. So in that case, this one is not a periodic function. And some people always have questions, as I should mention too, about the arrows at the end of periodic functions. Even though this arrow is pointed up, it doesn't mean it goes up forever in that direction. It's telling us that it's going to show you enough of the pattern, and it assumes that it would just keep going with that same pattern. Okay, so it doesn't mean that it extends to infinity. So the first piece of your assignment is to look at some graphs and decide, are they periodic? So do the y values, do the function values repeat? And if so, can you find the period? So pause here, maybe try that first part of the assignment, and then grab your note sheet and let's continue on with graphing sine, cosine, and tangent functions. Okay, so here, sine, cosine, and tangent functions are all periodic functions, hence why we're focusing on that. And we're going to use the values from the unit circle to graph these functions so you can start to see what they look like. Excuse me. So on your paper there, you have a little XY chart, which you see here, with some X values. All those X values are written in terms of radians. So when you look at your graph, the X-axis is an angle, so it's, in this case, it's in terms of radians. You could also write this in terms of degrees and get the same picture. We're going to stick to radians for right now. And so we're going to go pull those sine values off of our unit circle. If you recall, on this unit circle, when we have x and y, the x was the cosine value and y is the sine value, right? Now we have in this new graph, x is theta and y is the sine, okay? So we're just graphing one of these functions. We're just graphing the sine function right now. Your unit circle has both functions on it, okay? So let's start. We're going to go first to pi over 4. So I'm going to go to pi over 4 on my unit circle. The y value, which is the sine, is the square root of 2 over 2. So I'm going to pull that in there first. All right. Then the next radian is pi over 2. At pi over 2, the y value is 1. At 3 pi over 4, the y value is again square root of 2 over 2. At pi, the y value is 0. At 5 pi over 4, the y value is negative radical 2 over 2. At 3 pi over 2, the y value is negative 1. Oops. 7 pi over 4, again, we have negative radical 2 over 2. And then 2 pi, we have 0 again. Okay, now obviously they're not using every single radian. This is just to give us an idea. You could use all the radians in between these, the 30 degree, 60 degree, pi over 6, pi over 3, if you wanted to get a more accurate graph, but we're just trying to get the general shape down right now. And then one other piece here, I don't know about you, but I'm not super confident in what the square root of 2 over 2 is as a decimal. And really when I'm graphing it, decimals are going to be easier for me to understand than square root of 2 over 2. So let's calculate what that actually is on our calculator. All right, so we have, whoops, no, sorry. We have the square root of 2, which is 1.4, divided by 2. Why don't I know how to use this? 2 square root is equal to 1.4 divided by 2. There we go. It is 0.7. So these values here are approximately 0.7. So let's go ahead and graph this on our graph here. So I'm starting at pi over 4 as my x value, which is right here, okay? And the y value is 0.7. So this is 1, so it's got to be a little bit higher than half, all right? At pi over 2, which is the next x value labeled on my graph, we have positive 1. At 3 pi over 4, again, we have 0.7. At pi, we have 0. At 5 pi over 4, we have negative square root of 2 over 2, or negative 0.7. At 3 pi over 2, we have negative 1. And 7 pi over 4, we have negative 0.7. At 2 pi, we have 0. And if you went back and looked at 0, well, remember 0 is the same as 2 pi. We still get a y value of 0. Right? If you went backwards around your unit circle and went to negative pi over 4, well, negative pi over 4 is here. So that's the same as 7 pi over 4, which is negative square root of 2 over 2. And then we go to negative 1, negative square root of 2 over 2, 0, positive square root of 2 over 2, positive 1, positive square root of 2 over 2, and 0. Now, you can trust me on that, or you can go back and verify if you want, but that's what it's going to look like. And if we go ahead and connect all these values here, my line was a little bit off, but get the idea. We get a periodic function. You can see that the y values are repeating themselves over and over and over. Okay, actually, let me try that one more time. So let's see if we can answer a couple questions about this sine function. First of all, what is the domain? If it keeps going to the right forever and it keeps going to the left forever, domain is going to be all real numbers. What would we say is the range? Well, if you look, it never goes higher than 1 and never goes lower than negative 1. So my range would be negative 1 to 1. Amplitude is another new word that we're going to talk about. The amplitude of a trigonometric function is the distance from the center of your function. Let me get a different color here. So the middle of our function falls at 0 to the highest or the lowest point. So it's the distance from the center to the top or the center to the bottom, and that should be the same distance. In our case, that distance is 1. So our amplitude is 1. Can you see that in yellow? All right, our period is how long it takes for this function to repeat itself. So if we look here, we started at 0. It went up, back down, and then back up. And it didn't start to repeat itself Oh, goodness. Until we got to 2 pi. So if I want to think about the period goes from 0 to 2 pi. Well, that distance then is 2 pi spaces. The zeros of the function, if you look at this, it's going to continue to hit the x-axis over and over and over again because it's repetitive, because it's periodic. But let's list off a couple that we see. So I see negative 2 pi. It hits the x-axis again at negative pi. It hits at 0, pi, 2 pi, and it's going to continue that way for a very long time, right? The absolute maximum, well, technically the highest point that it ever hits is positive 1. So here we talked about before that there's not really an absolute maximum when you have multiple points hitting the same y value, but the highest it ever goes is 1. So for all intents and purposes, we'll say the maximum is 1 and your minimum is negative 1. Never goes below that, never goes above that. All right. So I want you guys to pause and for you to try that with the cosine function. See what your graph looks like, find those values the same way, and then check back in and I will have done it out for you down below. And I'll do it as quickly as I can here. So cosine pi over 4 is going to be square root of 2 over 2, which we know to be 0.7 approximately. At pi over 2, we have 0, 1, so the value is 0. 3 pi over 4, we have negative square root of 2 over 2, which is approximately 0.7 negative. Pi, we have negative 1, 0, so we get negative 1. 5 pi over 4, we are down here, so the cosine's negative square root of 2 over 2, same x value as up above as the 3 pi over 4. So that's negative 0.7. 3 pi over 2 gives me 0, negative 1, so again 0. 7 pi over 4, positive square root of 2 over 2. And 2 pi gives me the 0.10, so we get 1. So if I graph those points, we have 0.7, we have 0, we have negative 0.7, negative 1, negative 0.7, 0, 0.7, positive 1, and if we went back to 0, we get positive 1, if we went back here. So if I connect this, it looks a little different. Try not to connect it like a V shape. Keep that same sort of curve. It should look really similar to the sine function. We're just seeing a different portion of it, right? So we're seeing from the top of a peak to the end of another peak, whereas with the sine function, it started at 0, 0. The cosine function starts at 0, 1. That's the main difference there. Sine always starts in the middle, cosine starts at the top of your amplitude. And we could reverse this and go backwards if we wanted to. And you'd see that that looks almost the same as the sine function. We're just sectioning off a different piece, where it starts in a different place. It's the exact same curve, just shifted, and there's multiple ways you can shift it to get the same picture, but that's one of the ways. So if we talk about the domain, a lot of this is still the same. Domain is negative infinity to positive infinity, range negative 1 to 1, amplitude still 1, that's the distance from the center to the top. Period, so this time we went from here down and back up, and that's where it would start to repeat itself again. Well, that again is a distance of 2 pi spaces. From 0 to 2 pi is 2 pi spaces, so that's my period. The zeros this time are on the halves, if you notice, so we have negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, etc. Max is 1, min is negative 1. All right, and then so sine and cosine are really closely related. And then the tangent function here is going to be a combination of the two graphs. So if you think about what we talked about before, that tangent is the sine divided by the cosine, or if we talk about the unit circle, y divided by x, well, that means that we're going to take the function values and calculate our tangent from these angles here on the unit circle. So I'm going to go ahead and pull that unit circle down so it's a little easier for us to use. Maybe I'll just add a new one. Sorry, bear with me. Okay, so the first thing we're going to do is find the tangent of pi over 4. So hopefully you've memorized your unit circle at this point, right? So when we look there, the tangent is going to be y over x. So square root of 2 over 2 divided by the square root of 2 over 2. When we divide something by itself, it's just equal to 1. Right? So tangent of pi over 4 is 1. Then we get to pi over 2. Y over x would be 1 over 0, which means it's going to be undefined. What do you think it looks like on our graph when we get a spot that's undefined? Remember, we have a few options. You can have a hole in your graph or an asymptote. In this case, anything that you see that's undefined is going to become an asymptote. So we know we have one at pi over 2. 3 pi over 4, we have negative square root of 2 over 2 and square root of 2 over 2. When we divide those, we're just going to get negative 1. At pi, we would have 0 over negative 1, which would just be 0. 5 pi over 4, we're dividing negative square root of 2 over 2 by negative square root of 2 over 2, so that would just become positive 1. 3 pi over 2, again, negative 1 over 0, undefined. So another asymptote at 3 pi over 2. 7 pi over 4, negative square root of 2 over 2 divided by square root of 2 over 2 is negative 1. And 2 pi is 0 over 1, so 0. So let me plot those points there, and let's see what we come up with. So pi over 4, we have 1. Pi over 2, we have an asymptote. 3 pi over 4, I have negative 1. Pi of 0. And 5 pi over 4, I have 1. 3 pi over 2, I have an asymptote. And 7 pi over 4, I have negative 1. 2 pi of 0. We went one more, it would be positive 1. Similarly, I'll backtrack this a little bit here so you can see what would happen. All right, so if I connect these, what it almost looks like is a cubic type function that flows in between each set of asymptotes. All right, so it's connecting through those 3 dots. When we look at this here, the first thing we want to look at is the domain. Well, and you notice that this doesn't look like either of the other 2 graphs, but I would argue that it's still periodic, right? Still repeating itself. So when we talk about domain here, I'm going to look at all the x values that we're using. Well, remember, anywhere we have an asymptote, we can't actually use that value. So domain would be all real numbers x, such that x cannot equal any asymptotes that we have. So pi over 2, 3 pi over 2, and we can say dot 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 because it's going to continue in that pattern. And then the range, well, this guy is going down to negative infinity and up to positive infinity, so all real numbers. When we talk about a tangent function, there's no longer an amplitude because there's no barrier, top and bottom, right? So amplitude, we don't have one. A period, though, we do. So look at how long it takes for this graph to repeat itself, all right? So when I go, it's easiest to look between the asymptotes, right? From one asymptote to the next, what's the distance it takes for that graph to repeat? Well, it goes from pi over 2 to 3 pi over 2, right? So think about what are they adding from pi over 2 to get to 3 pi over 2. Well, this is 1 pi over 2, so they had to add 2 pi over 2, or 1 pi, to get to 3 pi over 2. So our period here is 1 pi instead of 2 pi. That's the big difference. And then with tangents versus the other types of functions. And then your zeros, well, we have one at 0, pi, 2 pi, etc. So those are your three basic functions here, your basic parent functions. So hopefully you've filled those in. And then here's just a few tidbits about them, if you're still hanging with me. So properties, and we've talked about all these already, but for sine and cosine here, period is 2 pi, so those are the same. Domain, set of all real numbers, same. The range is between -1 and 1. X-intercepts are located at pi n for sine, and pi over 2 plus pi n. So we're adding any multiple of pi to get the next one. Y-intercept is 0. Y-intercept is 1 for cosine. So similarities I'm highlighting in green, differences in orange. The max and min values are 1, and min is -1. And you can look at where they occur. Oops, I used the wrong color. The max and min values are the same, but where they occur is the difference, right? So where they're actually happening on the x values of the graph is the difference. And then you can sort of see just a quick version of those charts and graphs with a little bit more detail if you wanted to take a look. So with that being said, if you haven't done the periodic functions there, go and try that. And then there's a few quiz questions that will be your score for today. Remember, you're just trying to get to passing, so you want to make sure it's a 60% or above. You have multiple attempts.